Welcome, guys. It's me, Mr. Aguilar here, just talking to you guys. Monday, you guys have a lesson today. Just want to recap so we're not super far behind. Recapping the material from yesterday. You should have the homework done. Giving you, I believe, only 4 problems. I'll have answers for you guys tomorrow, as well as additional notes we can cover. Looking at the ambiguous cases from yesterday, I know we talked about it. My first period, we didn't get it done. Second period, we did. So if you need to skip over it, you definitely can. And then we're going to talk about lesson 2, where we'll get started in just a moment. In our ambiguous cases, we have 2 different ways of looking at it. And just a recap of it, is the opposite side bigger or smaller than the other side? And this is what we're going to look for. In our bigger case, there's only one case. We can do law of signs to solve it. In our smaller case, we're going to have the ambiguous case in which we can have 3 solutions. So let's just kind of identify what we're going to be looking for these types of questions. We have these values here, and we want to be able to set them up in such a way that we can determine how many solutions these triangles have. Grouping our terms together, the opposite side is this is the angle and its opposite side. Is this opposite side larger than the B? So in this case, is A greater than or less than B? In this case, it's greater. This doesn't fit into our category. Our second category, if A is bigger than B, then we say it is one solution. And we're going to be able to solve this out. So it fits underneath this category, so we just say it has one solution. And we'll kind of keep on going with this. The next one that we get down below, we're going to go ahead and separate again. The angle and its opposite side correspond to these 2. Is this one larger than its original? And we say no, this is A is less than B. So it fits into our ambiguous case category. And we got to be able to use this idea of sine of B is equal to B times sine of A over A, sorry. So we have our case here, and we can go ahead and plug in our values that are representative for each one of these numbers. Our B value is 248.6 times sine of A, which is 43.1 all over sine of 186.2. When you guys plug this into your calculator, I'm going to kind of do this in live time. 248.6 sine of 43.1 divided by 186.2. We get 0.91. Okay, I'm just doing that, showing you guys there. 0.91 tells me that in our solutions, if our number is less than 1, if it's not that less than 1. If we have it less than 1, we have 2 solutions. So we can have 2 solutions with our example here. And so we're kind of done with this problem. Our third one here, the angle and its opposite side is 70. We can kind of denote this as 122, so we can see where we can verify whether this is greater or less. And so is the opposite side, which A, is greater than B, its other side. So we say that A is less than B. So again, it fits into this ambiguous case category. So again, we have to use this law of signs in order to help us out. So we're going to use B times sine of A all over A. So we're going to get B, which is 122, sine of 42 over 70 for the other side. 122 sine of 42 all over 70 is going to give us, I don't know if you guys can see that, 1.16. So this number is larger. The angle is larger than 1, so it fits into our last category, which means it has no solution. We cannot construct a triangle that would represent these angles and sides. So that's all I wanted you guys to take away from this. And let's just look at the other kind of cases as we kind of go along. I'm going to clear these, so you can always pause it and go back. I'm going to make sure we're still recording right now. So it looks like we are, so we're still good. And let's look at our other case. We don't have to really discuss this, but looking at the kind of corresponding sides to this, the opposite angle and its side kind of correspond. So A is bigger than B. We have our one case or one solution. We don't really need to keep on going with that. We know we have one solution with us, so we don't really need to keep on going. We know it's bigger, we're done. This does not fit into this category in the ambiguous case, so we're going to continue. The next one is still same thing, right? C, even given other sides, the part that kind of corresponds with it is this. Its opposite side is still, whoa. Let's clear this. Sorry, messing up on me. So is its opposite side larger than B? And we say that this is our opposite side. It is larger than B. So we're still okay. It still fits in this ambiguous case. Want to look for one that doesn't. This one doesn't. So let's look at this case. Even if it's not next to it, we say that our opposite sides and its opposite angle is here. Is 19 bigger than 74? So is B greater than A? And we say no, it's smaller. So we look at the smaller case. And this fits into our ambiguous cases. So we got to be able to use this sine of B is equal to B sine of A all over A. And just by plugging in our values, let's see how many solutions our triangle can have. We say 19 sine of 87 all over 54.7. Sorry for my penmanship. I'm trying to get to the next lesson so we don't spend too much time on this. Sine of 87 over 54.7. So in this case, if you plugged it in correctly, you're going to get 0.34. So 0.34 tells me that it's less than 1, so I'm going to have 2 solutions. So that's all I'm asking you guys to check on. If your opposite side is greater than the other side, okay, then we know it's one solution. And if this opposite side and the other side are less than or smaller, we know it fits into this ambiguous case. And we'll practice one when I come back on Wednesday, okay? So that was that lesson. Let's go ahead and move on to law of cosines. Law of cosines is another rule we can use in order to help us solve, okay? We can use this to solve for angles or sides given missing parts to each part of them. In law of sines, we only were given 2 sides of it, 2 sides and an angle and a side. This is the cases we can look at, but still similar triangle from yesterday, we can use law of sines. So pause it if you need to. I'm going to keep on going. Copy down all those 3 for me. So looking at this, it says find the angles of the triangle. So in law of sines, we had at least been given a portion of our angles to use, and we weren't really given, okay, with those. So we want to be able to use, and I'm going to kind of take a quick picture of this so I can see my law of sines for us. But we want to be able to use our triangle here, the law of sines, for a side-side-side congruency. So it's really as simple as choosing one. We're solving for the missing angles. We're definitely going to need at least to do it to twice of them, or you can use law of sines to law of cosines. So I'm going to go ahead and start with our first one. A squared is equal to B squared plus C squared minus 2AB cosine of A. Okay. And we can use it by just plugging in our missing parts. Our A component is 5 squared. The B component is A squared. The C component is 12 minus 2 times A, which is 5, times B, which is 8, and then cosine of A. So we're signifying that we're going to solve for this A angle right here. And all you're really doing is you're solving backwards. So you're going to simplify everything. We're going to get 25 is equal to 64 and 12 gives me 76. And 64 and 12. And then minus 80 cosine of A. Again, just simplifying out our terms. We're going to go ahead and subtract out 25 and 76. We're going to get negative 51 is equal to negative 80 cosine of A. We're going to divide both sides by 80 to get 51 over 80 is equal to cosine of A. In order for us to solve for angles, we need to use cosine inverse. So we're going to use cosine inverse of that angle 51 over 80. 51 cosine inverse. To get our value, which is going to be 50.39. And all I did was I applied the cosine inverse function, cosine inverse of 51 over 80. So I got this to give me my final answer. So that's one of our angles. That's angle A. And we can use it to solve for B. We can use the other one to solve for angle B, which we're going to kind of show really quickly so I don't spend too much time. But I want you guys to do this one. This is B squared is equal to A squared plus C squared minus 2AC cosine B. Okay, we can use the same values as the picture is shown and plug it in directly into our values. We get B squared, which is, so 8 squared is equal to 5 squared. Plus C squared. If you look at your C squared, it's going to be 12 squared minus 2 times AC. So I'm just going to kind of abbreviate this and put it as 60 cosine of B. I'm going to do a lot of simplification, so I hope you guys trust me. We're going to do 64. 25, or 5 squared is 25, 12 squared is 144. 169 minus 120 cosine B. And 64 minus 169, negative 105, negative 120 cosine B. We're going to divide the two, so I'm going to get the ratio, negative 105. Sorry, when we divide these out, we're going to get a positive value. So when we divide 105 into 120, it's going to give us a positive. And again, in order for us to solve for the angle, we use cosine inverse. Cosine inverse of 105, 120, and that's going to give us our second one. So cosine inverse 105 over 120 gives me 28.95. So that's our second angle. So we have our second angle here. So knowing that we have these, this is 28.5. We have our other angle here, which is 50.39. If we know two of the angles, can we solve for angle C? Hopefully you guys are way ahead of me. In order for us to do that, we can simply do the supplementary angle. So 180 minus angle A minus angle B. So if you do that correctly, 180 minus 50.39 minus 28.5, we're given 101.11. So we have all of our three angles. We have 101 for angle C, 50.39 for angle A, and 28.95 for angle B. So this is using the law of sines for the first case. This is using it to solve for angles. Okay, let's look at our other example. We're going to do a little bit of Hurons formula, which is pretty simple. It looks very similar to the distance formula. And then we're pretty much done. Quick 3 little examples here. So I'm going to check to see if we're still recording. And we are, so we're still good. Checking my pen. For the next one, it says, find A using law of cosine. So We want to be able to see the relationship that it gives us. In this case that I'm seeing here, I'm giving a cosine of A. So I'm going to use the first term. I'm going to use the first formula. A squared is equal to B squared plus C squared minus 2BC cosine of A. And again, we're solving for A, so all we got to do is plug back in our values. A is what we don't know, so we're going to put a question mark on that one and leave that blank. B is 10.5 squared. C is 18 minus 2 times BC, so 10.5 times 18. And then we also know that this is cosine of angle A, which is 46.5. So we actually have all the information we really need. A squared remains the same. I'm going to plug all this into my calculator, and you can do that. Make sure you put parentheses around your values. 10.5 squared plus 18 squared minus 2 times 10 times 10.5 times 18 times cosine of 45 or 46.5. Ooh, it's a long way to write this. Let's keep on doing this. X. And in my parentheses, minus 6.5. $22.5 times 18. Ooh, man. What's it in there? 174.05. Want to make sure I did this right for you guys before I kind of continued. Please verify with me if I'm doing this correct. It helps me out. Okay. And then in order for us to solve for A, we take the square root. So we can solve this by taking the square root to both sides to get our final answer. So again, enter square root of my answer. So you can do square root of your answer. Hopefully it looks something like that. And we can get the answer, which is going to be 13.19. That's the side length for A. And that's all it's really asking us to solve out for. So we're good on that one. So that's all I wanted you guys to take away from law of cosines for both a side case and a side angle side case. And this is what's kind of providing. Okay, so that deals with law of cosines. Pretty much what we've been doing is being able to apply the theorems. The next one we're going to be doing here is Hurons formula. Given an oblique, okay, an oblique triangle, we can actually solve for the area by finding our cases where we have the semi-perimeter and we have the side length. So the semi-perimeter is what you guys need to take away from that is there. S is equal to 1/2 A plus B plus C. And that is half the perimeter. And that's what's called semi-perimeter. And then we take those and we plug them in directly. So pause it, copy that down. Okay, we're going to kind of move on. I'm going to do the same. Copy, let you guys copy. And here we go. So with Hurons formula, we want to be able to apply it in a simple kind of manner. We need 3 of the equations. So I'm going to kind of write this one out. I should have just wrote it on here. A is equal to square root of S minus A, S minus B, S minus C. And as long as we can find those values, we can plug it directly into our function, and we can get the area of an oblique triangle or missing side. So we can find it using 3 sides in the semi-perimeter. So the semi-perimeter is 1/2 AB plus B plus C. It's a semi-perimeter, so it's half the perimeter. I'm hoping you guys can add these. So 4 and 6 is 10. 10 and 3 is 13. So we're going to get half of 13. Okay, half of 13, and I'm losing a break of how to do this. So 0.5. I know, sad. Half of 13 is 6.5. I should have known that. I knew that. I was just testing you. Okay. And all we got to really do is plug in our other values to find the area. And it's really as simple as that. Hurons formula is, I can't ask you really anything more than that. Can't ask you to really go backwards for these. So just asking you to apply it directly. 6.5. And then we're going to take 6.5 minus 4, which is side A. Doesn't matter what side you make them. 6.5 minus B, which is 6. 6.5 minus 3, which is our last part of this. So again, this is all directly you can plug into your formulas here. So 6.5 minus 4, 6.5 minus 6, 6.5 minus 3. 6.5 minus 4, 6.5. I want to make sure again that this is correct. When you plug this into your calculator, we're going to get area is equal to 5.33. So again, it's as simple as plugging in your values for these. And that's it. That's it. That's how you apply Hurons formula. So I'm going to give you some homework problems from yesterday, being able to first determine how many, given an oblique triangle, whether it has one or the ambiguous cases. I'm going to give you a couple problems on the law of sines formula, being able to apply a little bit of them, and then the last two being law of sines and law of cosines. So if you want any more reference material, just turn the page over. It should have the problems that go with it. Again, you can find the area using the links of the sines. We don't really need to do that. Here's our problems that you guys can do. Law of cosines for these. I'm going to give you the handout for this, so you guys don't need to worry about it, okay? So I hope that didn't take too long, and I will see you guys later. Thank you. Okay. Still pouring rain outside, so let me try to finish this up for you guys. Bye, guys. Bye.